Hi, I'm John, and this is another high voltage power supply I've created, this time using microwave oven transformers. I wanted to create a high current high voltage output, so this time I'm using mains current and these high voltage microwave oven transformers. Okay, so the mains comes in here. I'm using this light switch to turn this circuit on and off, and I have a 15 amp circuit breaker connected with the light switch. The power comes to here where I have connected both cores together with a ground, and the primaries of the transformers are connected in series. This transformer is just being used as a ballast. I have, you can see the secondary here connected to ground, so that's just used to limit the current, and this one solely produces the high voltage output. The high voltage output comes here, which is connected to my spark gap, and the return of which is connected right here back to ground. Okay, to start with, I'm going to show you the high voltage discharge of the AC mains current. Notice how the discharges from this are much more like a flame than the discharges from my flyback transformer. So now I'll put this magnet under the spark gap and show you how the magnetic field affects the mains current. So with the alternating current, you can really see how the discharges blow out to both sides. Now what I'll do is I'll hook up a doubler circuit, the same one that's used with microwaves. So I have the original microwave capacitor here, and I'll hook that up so that it doubles one pulse, and then the other pulse will just be like charging the capacitor. Okay, so now I have it hooked up where the output of the secondary comes to this capacitor, which then can go through the diode to ground. So during one phase of the AC, it will charge the capacitor, and during the other phase, the diode can't be used, so the current will have to come through the spark gap through the secondary. So now what I'll do is I'll run the circuit, and I'll show you how the discharges without the magnetic field first look, and then we'll introduce the magnetic field and show you what that's like. So first, here's the discharges without the magnetic field. So it's pulsed like you would expect from the capacitor, and because there's not a continuous current, it can't maintain the arc. But notice what happens when I use the magnetic field. It becomes really intense, and it's only in one direction. So compared to my flyback transformer discharges, using high current makes a really big difference when it comes to using magnetic field to quench the spark. This also corresponds a whole lot more with what I've been researching on Tesla in his lecture on light and high frequency phenomena. You can check out all the details about how I'm relating to that and like kind of why I'm doing this and where I'm going with it. So check out my website if you're looking at this on on YouTube. It's up here in the info. Thanks.